This is part 2 of solving equations with a radical. Oh, I get it. Radical equations. Yes, that's right. We're solving radical equations. And one day you'll be taking some test that's super important because there are all these people who look really, really smart and they go, you have to be able to do this test. And you'll forget that when you solve a radical equation, the first thing you need to do is get that radical by itself. Get it by its lonesome. Get it all by its lonesome, man. Okay, I'm going to first, let's see, divide both sides by 4 or subtract both 3 on both sides. Well, you always do addition or subtraction properties of equality before multiplication and division. Well, at least it's easier to do it that way. If I subtract 3 from both sides, I get 4 times the radical x plus 2 is equal to 16. I don't even know. Is that a British accent? Who knows? If I divided both sides by 4, I would have had to divide the entire expression by 4. I would have gotten 3/4. And I know fractions like freak you all out. But anyways, divide both sides by 4. And now I get this awesome radical by itself. It reminds me of when we were solving absolute value equations and you'd want to get the absolute value by itself. Very, very much the same kind of thing. Okay, what did we learn in the last video? We learned that we can square both sides of an equation and maintain equality. And so when you square a square root, the radicand just comes out by itself. Boom, by itself. It looks equals 16. Subtract 2 from both sides, I get x equals 14. But when I squared both sides, there's the possibility that I suddenly get an extraneous solution, right? And so what we need to do is we need to check for those extraneous solutions. Is 14 really a solution to this equation? I'm not sure, but I will say this. We had done the properties of equality right up until this point. The square root of x plus 2 is equal to 4. If I substitute 14 in for x, 14 plus 2 is 16. The square root of 16 is equal to 4. So far, we haven't had any of these extraneous solutions. So I don't know what gives, but we'll have to just keep checking and see if we see a pattern when they actually come out. Solve. What does it mean to solve? It means to find the solution, which means to find all the values of the variable or variables that make the mathematical sentence true. We have square roots on both sides this time. My problems just keep getting worse. I can't believe this. This is ridiculous. I'm getting rocked in Battle Royale. This is ridiculous. I saw this girl do a TikTok video and she flapped her arms so fast she flew away. Okay, so if I have square roots, I have radicals. The radicals are already by themselves. I guess I can just square them both. Let's see what happens. We're going to find out. We're going to find out together. 2x minus 1 is equal to x plus 4. Well, this seems to be going well so far. I'm going to subtract x from both sides. I'm going to add 1 to both sides. So I'm really subtracting x plus 1. Or sorry, I'm adding negative x plus 1. Okay, this is 2x minus x is x equals, and that's 0. X minus x is 0. 4 plus 1 is 5. Okay, it looks like 5 is a solution, but we squared both sides. That's a non-invertible operation. Let's see if this 5 actually makes this true. 2 times 5 is 10, minus 1 is 9. Square root of 9 is 3. 5 plus 4 is 9. The square root of 9 is 3. It looks like we haven't had even one extraneous solution yet. Not even one. Don't worry, they're coming. They're coming. When they get here, they're going to hit you hard and they're going to hit you fast. They're going to hit you in the crux of that biscuit. All right, next one. Let's try this one. Oh my gosh. The index is 3. We're being asked to solve a cube root. This is so hard. Mr. Plunkett, it just keeps throwing crazier stuff at us. I wish math would just have stopped when I was in 2nd grade. No, you don't. You like the challenge. Well, if we can square both sides of an equation, do you think we can cube both sides of an equation? I mean, if 2 is equal to 2, let's just do like a little thought box here. If 2 is equal to 2, if I decide to cube both sides, I get 8 equals 8. Yeah, you can cube both sides. Let's do it. Okay, so when I cube this, I have 3 factors of the cube root of 5x minus 2, so that leaves me with 5x minus 2. And then I have to do 12 cubed. I'm going to use this amazing Windows calculator that I have here that loads very slowly. And I have 12. I don't even have a power, huh? I'm just going to have to do 3 factors of 12. Well, that's okay. I knew it was 144. I don't know why I did it twice. Okay, 1,728. 1 group of 1,000, 7 groups of 100, and 2 groups of 10, and 8 groups of 1. Come in car. Okay, so now I can divide both sides by 5, which is fine, right? If you divide both sides of an equation by the same number, you maintain equality. Or you could add 2 to both sides. Of course, we add. And I get 5x equals 1730. Good year, 1730. And I'm going to take 1730 and divide by 5. You know, I'm not going to use a calculator. I'm going to challenge myself, okay? I'm going to challenge myself. Let's see what we get. 5 goes into 17 3 times with 2 left over, right? 23. 5 goes into 23 4 times, right? And then there's 3 left over, and then 30. And then 30 divided by 5 is 6. I think I'm right, but you know what? I'm going to verify with my calculator. I'm going to hit the C, which means clear. I didn't know that until like last year. 1730 divided by 5. Oh, yeah! Okay, but now I have to make sure this actually works, right? I don't even have a cube root on my calculator. All right, everybody, can you make sure that I have this right? I'm pretty sure I have this right. I'm pretty sure. I don't know. You know, I could actually do this. I could do 346 times 5 equals that minus 2. Oh, you know what I'm going to get. 1728. Good year. All right. Excellent. Spain and England were probably in a war. Okay, so good. We have x equals 346. Life is good. We still have not had one extraneous solution. It's cray-cray. But guess what? That's all going to change. Solve. Is the radical by itself? Yes. What do I do to both sides? Square it. Oh no, how do you solve an equation when you have x squared and you have x? Breathe, relax, turn that into a quadratic equation. I'm going to subtract x from both sides and subtract 6 from both sides. And at this point, you have a lot of ways of solving this. We can solve this using the zero product property by factoring this. We can solve this using the quadratic formula, right? A is 1, B is -1, C is -6. You could solve this by completing the square and then solving the equation that you end up getting. I'm going to solve it by using the zero product property because I think this is pretty easily factorable. In fact, I could use my little x method. I may as well, so you all see it. Attic 1 times -6, that's -6. Basement -1. What multiplies to -6 and adds to -1? I do believe that that's -3 times +2. And then remember, you make this a fraction over a, which is 1. So there's nothing to reduce here. So that's 1x minus 3, 1x plus 2. Beautiful, equals 0. And then using the zero product property, of course, factor a, and I'll highlight it, even though I know you all remember this, but it's just good for you to see it again. Factor a is x minus 3, and factor b, factors of course are being multiplied, factor b is x plus 2, right? If either one of those factors is 0, then this equation is true. So we can make either x minus 3 could be 0, or x plus 2 could be 0. And of course, we end up with 2 solutions, x equals 3 and x equals -2. Well, that's different. We haven't gotten 2 solutions before. So let's check for extraneous solutions because we did end up squaring both sides at the beginning. If I substitute 3 in here, 3 is equal to the square root of 3 plus 6. Well, 3 plus 6 is 9. Square root of 9 is 3. We still haven't gotten one extraneous solution. I'll give anybody credit if they know this quote. When are we going to get to the fireworks factory? All right, but anyway. All right, negative 2. Negative 2 is equal to the square root. Well, negative 2 plus 6 is 4. The square root of 4 is positive 2. Negative 2 is not equal to positive 2. This is an extraneous solution. Okay, why is there an extraneous solution? The reason why is in these previous examples, the side of the equation that was the opposite side of the one with the radical was just a number. In this case, the opposite side of the equation with the radical is a variable. Because of that, when you square the variable, if that happened to be a negative number, it suddenly becomes positive. And that's why this is an extraneous solution. Because if you square negative 2, right here, you get positive 4. And negative 2 plus 6 is 4. And so the square root of that, well, I shouldn't say it, we squared it. So this would be negative 2 plus 6, which is 4. So you get 4 equals 4. But when we squared it, we took away that negative. And that's what made this an extraneous solution. So now what about this one? Do you anticipate that this one will have an extraneous solution? First, we get the radical by itself by subtracting 13 from both sides. And I get negative 10. Whoa, 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 whoa. Right now, you should see that something's up. Can I ever take the square root of a number and get a negative? I already know there's no solution. But I may not know that when I'm really in the heat of doing a test. So I may end up just squaring both sides here and going, yeah, I can do this. I could just square both sides. And I get 5n is equal to 100. Divide both sides by 5, and I get n equals 20. And I think, good, everything's cool, n equals 20. Well, 5 times 20 is 100. Square root of 100 is 10. 10 plus 13 is 23. But remember when we squared it, that 10, that would have become negative 10, right? And so you would have had 13 minus 10 if it was the negative root, and then you would have gotten 3. So this is an extraneous solution. In either case, if I substitute that in, it doesn't make it true. And so once again, there's no solution to this equation. Excellent, everybody. You are all radical in my eyes. Keep flapping your wings and those arms in those TikTok videos and fly away. Have a good one. I'll talk to you later. Bye.